Hello, welcome to CS225 Computer Science 2. I am Professor Garfield, the instructor for the course, and this is just an introductory lecture. It's the normal first day of the semester kind of lecture. I'm going to break it up into, I think, 3 pieces because, as we all know, watching someone walk through slides on a voiceover is absolutely brutal. And so rather than have one 50-minute lecture, I'll have 3 smaller lectures. What we'll cover here is give you a good course overview, basically walk through the syllabus, give you an expectation of what to understand. But before we get into that, some important information. There's no labs the first week of class. So this is the first week it's normally no labs. We'll pick up on the second week and then go from there. This is being offered online. Yes, we will have Zoom lectures. Attendance in class, when we have in-person class, I normally give a small grade percentage to attendance in order to strongly encourage people to attend. It's not required. Your attendance is not required. However, strongly encouraged. My experience is students who don't go to class fail the course. The time for the lectures, though, since Embry-Riddle has decided to eliminate our time slots, is still to be determined. So I've set up a doodle poll, and you can take the doodle poll. There's going to be a link in these notes, and there's going to be a link in the announcements, and then we'll just go from there. I'll try to I suspect we're going to end up with the originally timed slots, but I just want to make sure to accommodate people who maybe signed up for another class because that slot was free. There's a textbook for the course. We'll get into that. Yes, I recommend the textbook. We do not do homework from the text, but I do follow the textbook more or less in order. I follow examples from the text, or at least examples that are derived from the text in terms of coding examples. The access to the textbook does give you access to a lot of code examples. It's always good to have a textbook, in my opinion. Yes, there's some good online tutorials about languages and things like that, but it's always good to have a reference handy. I'm old. I believe in textbooks. Yes, you're going to need to download software to your computer. Lab 1, that's what it's all about. Specifically, you need to download Eclipse in Java, and so if you want to get ahead of the game, you can download Eclipse in Java. Some people have used Java previously, and they don't like Eclipse, or they're using some other kind of a development toolkit. I am perfectly fine with that. My only requirement is this: when you hand in your homework or hand in your projects, it has to run on the grader's machine and on my machine. So if you're becoming dependent upon some kind of a software development tool that I don't have, then I won't be able to grade your work. We'll provide links in the modules, and we'll provide links in the labs to both Eclipse and Java Software Developers Kit. You can take the course with a Mac. It works fine. Some courses, when they go online or when you're doing online stuff, as you know, Macs seem to not work the same as PCs. In this course, we've not found it to be a problem, though. So everything should be fine. Okay, now let's get into stuff. Module 00. Here we are. We're beginning with the first module, which is Module 0. And here's what you should know after looking through this module after our lecture on Monday. You should be able to identify the major themes: OO paradigm, object-oriented paradigm, software design, software development. Notice the word Java did not appear in there. Identify the course delivery components. You know, what do you need to do? Online notes, what am I going to do to get the information to you? Online notes, online lectures, live online courses. So I'm going to provide these slides as notes. I'm going to provide these lectures as recorded lectures, and then we'll have our normal course delivery through Zoom. One of the things I'm hoping with the live lectures is, since you have access to this, hopefully it can be more of a Q&A than what we often have in an in-person seating. You should be able to figure out what you're going to deliver for the course. So we're going to have quizzes, homeworks, labs, discussions on Canvas, and some project artifacts. So, when you turn in your project, you have to turn in stuff. And we'll talk about what that stuff is later. Identify what the course outcomes listed on the syllabus. There's a reason why you're taking this course. You should be able to go through the syllabus at the beginning of the course and say, oh, that's what I'm supposed to know when I leave. And then when you leave, look at it again. Figure out if you really did learn it. If not, professors are happy to help you. Other students are happy to help you. State the course grade breakdown. That seems to be the one that students like to focus on. We'll figure out how to get a grade in this course, and you'll be able to determine what your final course grade it will be based on the points that you earn. And also an estimate to time commitment to do well in the course. This is a 4-credit course, not trivial, not difficult, but there is effort involved. Okay, the 3 major themes. This is not the Java class. Everyone refers to this, oh, I took the Java class. Well, we don't have a Java class. We have Computer Science 2. And the job of Computer Science 2 is to introduce you to the object-oriented programming paradigm. The object-oriented programming paradigm is different from what you probably have seen in the past. I know a lot of you have taken Java in your high school AP courses, and that's great. But if you took MATLAB, C, C++, you were introduced to what's called the procedural or imperative paradigm. So what the procedural or imperative paradigm does is it says start here and just go down the list. Do the next thing, do the next thing, do the next thing. Objects work a little bit differently, and yes, we will talk a great deal about what that is. So objects work differently, you think a little bit differently, you design a little bit differently. Most languages today support both the imperative and the object-oriented paradigm. So when you become a software designer in the real world, the more tools you have available to use that language well, the better you are, the more valuable you are. In theory, the more valuable you are, the more valuably they pay you, in theory. Right now, object-oriented is the most widely used paradigm. Right now, Java is the most popular programming language, most widely used. It will be interesting to see how that changes in the near future because, as some of you know, Python is coming on strong, so we'll see what happens. By the way, Python supports both techniques, plus an additional one called the functional paradigm. It's an introduction to professional software development processes. So here, when you start out in a computer science curricula or a software engineering curricula and you start doing programs, by definition, you're going to do small academic programs that don't really teach you how to make large pieces of software. In this course, you're going to make a fairly large piece of software for your project, and we're doing that partly to give you an understanding of how you actually start to develop software. Now, those of you that have to take SE 300, you'll build on what you learn here and use in SE 300. And if you're taking future software engineering courses, then again, you keep building and get more and more sophisticated in what your software development processes are. Software design is a big deal. Meaning if you're a good software designer, again, you're valuable. It's implicitly difficult. It's a difficult task. Software design, software testing, software development is an implicitly difficult task in a different way than other engineering disciplines. In other engineering disciplines, I have a physical part. I can build it, I can hold it in my hand, I can turn it over and visualize it. You can't do that with software. We still have not really solved the difficulty problem with software. We currently are going to use the Agile process in this course, introduce you to the Agile process. I'm cheating it quite a bit because the Agile process is built for teams and you are a team of one. So we're going to give you the elements of that, and again, if you take SE 300, then you then take what you learned individually and put that into a team environment. The Agile process is currently the hot and heavy process used out in industry. We'll see if it's peaked, right? So in 10 years, who knows what people are going to be doing, but right now, everybody is doing Agile or trying to do some version of Agile, and there are many different versions out there. And we're going to teach you about software development in terms of the object-oriented paradigm, which is different than procedural. We're going to introduce you to data structures and algorithms also. That's the traditional heart and soul, by the way, of a Computer Science 2 course. Our sequence at Embry-Riddle is a little bit different from that. So this is a basic introduction to data structures and algorithms. And then when you take CS 315, those of you that do, then you get really hot and heavy into that. You get a lot more depth in that. However, what I found over the years is when I ask students to do projects and they don't know anything about data structures, then they have a really difficult time visualizing how they're going to create the product. And so this should give you enough of an introduction to the basic 7 or so data structures that are out there that it will help you complete your project. It will help you think better about how to solve problems in a computational way, how to develop algorithmic thinking, step-by-step thinking, foolproof thinking, mindless thinking, that kind of thing. So it should help with your project and give you a leg up on your CS 315 work. The course is delivered via Canvas. If you are not familiar with Canvas, there are some links in the module that give you some tutorials. And if you are, then it's, this isn't going to be a shocking thing. We'll break the course up into modules. Your view of Canvas will look more or less like this. This is the faculty view right now, but your view will look more or less like this. Announcement pages, modules. I've broken up the course content into modules, roughly 1 per week. Discussion sections. We don't have many of those, but there's a few activities that will require that. The assignments, grades so you can track your grades, and the people so you can find other people in the course and collaborate with them and get help from them and give help to them. Again, in a face-to-face setting, that happens naturally, right? You're sitting in the same room, you're bored because I'm talking, and so you start talking to your neighbor and you become kind of a team. Here we're going to do it virtually, so be aware that you are not taking this class alone, you're taking this class in a group. And then I will encourage you to collaborate and work with other members of your group. In some of the assignments, you'll do some peer review, so we'll encourage that and basically require that. Okay, so what do you have to do? This isn't a hard course. I don't see this as a hard course in the same way that people have trouble, say, with Physics 3 or Calc 3 or something like that, which are sometimes conceptually difficult courses. Thermodynamics, can be a conceptually difficult topic. This is not, in my opinion, conceptually difficult if you keep up with things, but you do have a fair amount of work to do. So this is because you never get good at anything unless you spend time doing it. So you do have to do the following. For each module, short quiz. Easy money. What do I mean by easy money? I mean, that's a grade booster, man. That's a place where you're going to pick up some points for very little time invested, and I'm going to make the quizzes fairly easy. It's basically, hey, are you at least paying attention kind of quiz. Complete 8 homework assignments. 6 of them are coding. 2 of them have to relate to software development. Complete 11 labs. Again, historically, that's easy money. Historically, students get a really high lab grade as long as they just show up and do the work. That's a place to boost your grade right there. Participate in 4 discussions as part of your project work, so that's going to be peer review, and then create and turn in 7 project deliverables, and we'll talk at great length about those. Basically, every Friday, we're going to do project stuff. I'm also going to have some extra credit opportunities along the line. Some of them are quizzes, some of them are doodle polls, some of them I'm hoping to get, some of them are discussions. I'm hoping to get some people to do, instead of on-campus lectures about what's going on in industry, I'm hoping to get them to come in via Zoom. And if you go to those, then that's a few free points there. So the extra credit opportunities are there. Is that a lot of work? Yes. But this is a 4-credit course. If you think about it, they always say 3 to 1, right? So if you have 15 credits, you should be spending 45 hours a week on your school, which is basically a full-time job. Right? Being a full-time student is a full-time job. This is a 4-credit course. You should expect about 12 hours per week. I have laid out what I think the time effort is, and I'm keeping it at about 12 hours per week. But I'm also going to ask you for feedback. So when you do a homework, and I think it's a 2-hour homework, I'm going to give you a doodle poll so you can tell me, yeah, that really was 2 hours, or, I spent 6 hours on it. As you would expect when we start doing coding homework, you do get wildly varying time estimates. Some people may finish it in the 2-hour time frame, and some people might take 4 or 5, 6 hours. Here's my recommendation to you. If you hit that 2-hour limit and you still don't think you're going to do well, or you're not sure what's going on with the homework, just stop and ask for help, please. Usually the people who spend 6 hours, they'll come into my office, I've spent all weekend on this, I don't understand it, and it's because of a basic misunderstanding, or, like a 5-minute conversation, and they're like, oh, okay, now I get it. So don't do that to yourself. If you're hitting a wall, stop and ask for help, please, from myself, from the TAs, Dean Laga, other students. If you want me to put up discussions, we can put up discussions, things like that. I will give you time estimates for the assignments, and for some of them they're fairly long. So some of them, like for a report, I'm going to say, I think you should spend 8 hours on this. Don't think you're going to spend 45 minutes on that and turn in something that's any good. If it's an 8-hour assignment, it's an 8-hour assignment. Now you might have 2 weeks to do that, but take those estimates seriously, please. Okay, again, it's not really tough, but man, you have to do the work. Okay, I think that's what we're going to do for the first part of this lecture. I'm going to stop here, and then I'm going to come back and do the syllabus overview for the second part.